Okay, good morning, everyone. We are starting the first talk on this track for today. It's about the lie of NoSQL, presented to you by Mike Elsmore. So please give him a warm welcome.
Just checking. Okay, that works. Right, morning, everybody. There's the title. There's the obligatory slide for me being here. This is a legal disclaimer because I happen to work at a massive corporation. I have to say that this allows me to talk about anything I want without having to worry about somebody suing me. So who am I? I am Mike Elsmore. I am developer advocate at IBM CDS. There's my email if you wish to send me hate mail afterwards. So I've just remembered I have my clicker in my pocket. IBM CDS. Anyone ever heard of that thing? Stony silence. I'll take that as a no. Right, we are a SaaS part of IBM, so all we do is we take all this stuff. Majority of it is open source, except for that one. No, actually, that's the open source one. There we go. That one aren't open source. Otherwise, all we do is take open source software and operationalize it. So like you, most of my day is spent hammering away at a keyboard, seeing what happens. Sometime around lunch, I will end up scratching my beard, trying to get, well, the attempt at beard I have right now, going, what the hell has happened today? And usually by the end of my day, I look like this, because my prototypes are not working and I can't work out when nothing is going right. And I'm going to apologize now, I am not a morning person, I am not caffeinated enough to give this talk. So if there's any mistakes, I do apologize. It's, one, I'm British, and two, I'm really tired. So I've got to admit, I am not an expert in any of these things. I am not a DBA, I'm a developer. I just happen to play with a lot of things and may have worked out some of the fallacies around this whilst doing so. And even more importantly, when it comes to some of it, it's very much my opinion. It is not fact. If it's in fact, it's probably off Wikipedia. Right. Now, I have a mildly inflammatory title. NoSQL is a lie. Who here believes in that title? Two people. I'm hoping to convince the rest of you by the end of this talk. Who here is aware of NoSQL technologies and uses them? Right, so most of you believe in the lie. So, first we have to begin with the rant. And this bit really does get me quite angry. The whole terminology around it, NoSQL. It was originally coined by Carlos Strozzi in 1998 for his Strozzi NoSQL database, which, I may add, was relational. It just didn't have an SQL interface. So the whole, NoSQL stands for everything that isn't relational is a lie. And then there's this horrible, horrible thought that if it isn't SQL, it's NoSQL. Who believes in that? Oh, nobody's going to admit to that. Yeah, because the horrible thing is, with Postgres's last two releases, they've had baked in a JSON instance for you to actually post things to. Oh, well, isn't that what every NoSQL database does? And then there's this horrible thing that was started by, I can never pronounce his name correctly, Johan Askason in 2009, when he started a event. He wanted to describe them all. So instead of like picking all the correct names and working everything out individually, he just picked everything and went, here's the NoSQL stuff. So it became this horrible backronym which went, Web 2.0 technologies, 2.0 technologies are NoSQL. They're really not. So NoSQL. NoSQL has SQL. Who here's had a play with Cassandra, Sparkle, or even Couchbase's SQL technologies recently? Right. Just like curiosity, does that mean there is SQL on NoSQL? Is it an SQL-like language? Do you read it right? Okay, ignoring that, but more importantly, Sparkle and CQL. Both of them are SQL interpretive languages that, yes, they don't contain joins, but they still work like SQL. To me, that means there is SQL on NoSQL. Agreed? Yeah, okay, so the whole NoSQL is a lie. There's a lot of the it's a lie bit coming along because it annoys me a lot. So, there's this great fallacy with them as well, which is NoSQL databases are schemaless. Who would admit to NoSQL databases are schemaless? Oh, Nobody else going to bite that bullet? You think that, don't you? It is very much depending on the technology, but still, the most common kind of NoSQL databases being Mongo, CouchDB, and Cassandra, they all are schemaless. You can throw in different shaped objects and it will adapt to it. That is a complete and utter lie. As developers, you implement a schema because if you don't know what's going into the database, you have no idea what you're getting out. So by nature, it has a schema. It's just been set by the developer in the application, not by a goddamn schema list inside of the goddamn tables. Anyone agree with this? Nobody's got, I've got a couple of nods. Okay, I'll take that as people agree that you are implementing a schema on top of a schemaless system. Thus, you have a schema. There's also this one. Who believes they are an NoSQL expert? You admit that. There are too many types of NoSQL expert for you to be a database expert in that. There are just too many distinct types. So please follow this, the GIF. You can be an expert in the specific technology. Do you use Mongo or Cassandra? That's not a NoSQL. Couchbase. You can't be an expert because the way each different type works is completely different. You wouldn't treat a key value store like a graph database. You wouldn't use a document store as a time series. They are very much different things. You can be an expert in implementing and running with the type, the specific technology, but you can't be an expert in all NoSQL at once. As far as I know, currently, there is over 90 different NoSQL technologies. If you're an expert in all of them, I need to get on my knees and bow down to you right now. If you're an expert in 50% of them, I need to bow down to you because you know a hell of a lot more than anybody on the planet I know. So, that's the end of my rant. Does everybody agree with that rant so far? Am I factually incorrect? I have an open heckle policy, so if you believe I am wrong, the only way I'm going to learn and fix this is by you telling me. Who here disagrees with me on these statements? Am I coming across way too aggressive for you to say anything to me? Right, I take that as a yes. Right, so I need to calm down. I need to be cool. I need to slow things down a bit. I do like my GIFs, can you tell? All right, now I'm going to have to drop some science on you for all of the next bit to make sense. I do apologize. If I start talking really, really fast, it's because I get a little bit animated about this stuff, and I like it. So if I'm talking too fast, just ask me to slow down. Okay? That was the yes-no answer. There we go. Thank you. Right. So enter CAP Theorem or Bowker's Law. Who knows about this? Right. So you're all aware of how it integrates with distributed systems, etc. So what Bowker's Law breaks down into is consistency, availability, and partition tolerance. They're the three cardinal pieces of it. So with consistency, it means what you put in is what you get out. So if you put a record with one object in, and it is one string containing string A, you will get string A out as part of that object. It's quite simple. It then iterates up, etc. You then have availability. So is the system always available? Or will it have fallen over for God knows what reason at some point in the day? And then there's partition tolerance. What that actually means is the system can actually take network faults, but in my mind, it actually means it knows where the data is. It knows which shard out the triplicates it's usually written into it's pointed at. So it knows where to look for things, in theory. So in CAP, that little thing there, I love the fact that it's still in the Venn diagrams. I think it should be a white space rather than a colored space. But trying to explain that to the designer person is really quite hard, because I can't draw diagrams or anything. I can't use Photoshop, so I didn't even attempt to make this. So you can be CA, AP, CP, but you can't be CAP. Okay? Okay with everybody? It's a completely pick-two scenario. So it's kind of like Heisenberg's uncertainty principle. You can know where something is or how fast it's going, but not both at the same times. Does that make sense? So why is this important? there's a little bit of history behind this, and some of this will be a lot of pain that, who here has been developing for more than, say, 8 years? Right, so the things I'm going to go through now are all things that we're going to have cried about in the last, well, in that 8 to 6 year block with the turn of commodity hardware on the internet.
I didn't understand your assertion about the fact that you can't have three.
I'm about to explain it. It's all about distributed computing. So, you can be consistent or available because in a distributed system you have to know where everything is, so you have to be partition tolerant. So you have to be partition tolerant, so you can only select one of the other two. So how they got around this was in distributed systems. Next slide. Distributed systems need to know where all the data is because everything is in a specific location. So that means you're partition tolerant and consistent or available. I've double checked the number of spaces that does represent consistent and available exactly. I counted them. So there was this major design decision with most of the NoSQL technologies at the time, so CouchDB being my favorite at the moment, well, favorite of all time at the moment, to be honest, with it going for an AP approach. So they decided to pick where everything was on the machines, but then they decide to drop consistency, so you have this eventual consistency model, which, trust me, when you try explaining it to people who've been doing DB2 for 10 years or more, it's a real pain in the backside to explain. So with these things, everything, because they're on distributed machines, if a machine drops down, if you're going for availability, if that machine's gone, your service isn't available. So you have multiple machines. And that means if one machine goes down, there's a couple of machines extra to take it on. The problem is there, if you want to be consistent across those three machines, if you're on a high traffic system and you're receiving millions of requests per second, it is going to be impossible due to network lag and anything to do with I/O on the machines to make sure each of the three machines is at an identical step at that point. So if you want to be available, you cannot be consistent. If you want to be consistent, you cannot be available. Does that make sense? How much do you remember of your distributed theorem?
Now, what you say is that I go to the limit, to the extreme, and under those conditions, I say that it's not possible for practical reasons to have all three conditions met.
That is correct. It is impossible at any production level on any large system to maintain a complete CAP set, just due to the fact that each machine is running independently. There is network and I/O on the machine, so they could be running on different hardware setups. One could be running on an AWS system, so using virtual hardware. Another could be running on bare metal using SSDs. Because of the fact they're completely different, you cannot maintain consistency across all the machines if you're aiming for availability. If you aim for consistency and drop availability, all you do is you start write locking and you make it consist across all the machines, but then you can't read it because you've locked the system to be able to write. Does that make sense?
You can continue.
Thank you. Right. However, just to be completely fair, there is this thing called NoSQL. Who's heard of this? I only discovered it about 3 months ago. Right. NoSQL comes out primarily Google and the project Google Spanner, which is a further iteration on Bigtable. Bigtable being, you know, their big NoSQL infrastructure that everybody can get onto as part of the app cloud. Spanner is an attempt, well, it's a quite successful attempt, to create a SQL system which is consistent and available across machines. Nuts. There's a specific algorithm it's using to maintain this state across all machines, and I really should have written that down here on my speaker notes so I could remember to tell you what it is, which will help maintain it. At the moment, this is still quite expensive because it does rely on a lot of hardware to just maintain the consistency. For example, each machine has to have a connection to a GPS and atomic clock to contain state, to make sure it keeps state between everything. So that's kind of bulky. However, Google Spanner is being used across the entirety of Google, and considering we all know how big their infrastructure and how big they do their things, you've got to know it's kind of resilient and kind of works. The only reason I found out about this was because of something called CockroachDB. Who's heard of this? Turns out some guys from Google decided they wanted to make an open source version of it for everybody, and they're in the process of producing it as CockroachDB. It's really quite good, but it's still quite early stages. But this solves the whole consistency and availability thing by completely changing how it actually interprets I/O and reads for it. You can have CAP, but not with NoSQL. All right, so the types we're going to cover today are key value, document, column, and graph. And we're going to go through just roughly what they are so that people who aren't aware of the different types know what they are and some use cases for them. So now we know that we can get the right tool for the job. There are hundreds of other different types. 1, 2, 3, 4, 5, and there's a bunch of others. We're completely skipping multi-model because it's where they've designed the system to be in memory and have multiple index types, so you can interpret it as different kinds of databases. It's kind of hard to talk about different types when one of them kind of does it all. It's like saying, I'm going to bring a knife to a fight. No, I'm just going to bring the army. Right, so we're going to completely skip across multi-model. Is that okay? Cool. This bit, as you may have told, is going to contain some audience participation. Who's up for that? There we go. Happy, smiley people you are. Right, so we've got key value data stores. You know, they're these things that are essentially hashes, dictionaries, arrays, whatever you want to call them. So you look up on the key, you get the value. It's kind of self-explanatory. Who can name some? Pardon? Berkeley DB, yes. Pardon? Yes, I didn't realize that was actually a key value store until relatively recently. It's amazing. Yeah. Any more? Technically, but they're not at NoSQL. We're sticking to NoSQL here. I'm trying to prove the lie of NoSQL first. All right, so we'll skip that slide because I didn't finish it. But here is a lot of key value stores. Yeah, they're open source and closed source, but I thought the only way to point out completeness would be to give you a complete list of everything I could find. I've only actually experimented with about 8 of these. So when I was saying you can't be an expert in everything, if you could be an expert in all these key value stores and all their edge cases, you're a genius, an utter god among developers. But yeah, has anyone played with any of those that are slightly more obscure and haven't been listed off? Because I really want to find a reason to play with some more of them. Okay, I'll just have to invent another reason for myself. So what is a key value store? It's kind of simple. It's a key and a value. You pull it out. These usually are complete available systems, so they're AP-based. So they rely on the fact that everything's going to be lightning quick on the indexes so that they don't lock up the system. It does mean a lot of them rely on memory or SSDs to run quickly. So it's usually nice to have a cluster of big, fat, memory-filled machines without that much disk to do the job. Seems quite reasonable. And they're just, as I was saying, hashes, dictionaries, array, whatever you want to call them, that's just what they are. You just call it as if you would in any code. Why would you use key value stores? Right, anything you want really, really quick without any form of complex querying. That is what you want an index for. Most common use cases I've seen are, and I've used myself, is for queues, sessions, and just ridiculously fast lookups. I shouldn't press the button whilst I'm halfway through slapping my own hand. It's a really, really simple model, but really, really powerful when you're doing the correct thing with it. Now we have document databases. Yes, my favorite bit. Who can name some of these? You said Couchbase? Yeah, that's it. That is a document database. Technically, it's what happened when Membase and CouchDB smushed together. It's like the love child of them, the proprietary technology. Anyone for anything else? Or shall I just skip to the next slide with a big list of them? MongoDB, yes. The most popular one in the world. Without a fact, it's just so easy to run with. It's just that popular. And the query language is really simple to get your head around. So, Cloudant, because they paid me to come here, so I put their name first, of course. And then there's CouchDB, Mongo, Couchbase, RethinkDB, which is essentially MongoDB, but when somebody went, the engine's not good enough, we'll rewrite our own. And then, my favorite one as well there, PouchDB. Technically an in-memory database for browsers, also a node library, also something built on top of LevelDB. I like it a lot. Anyone heard of any of those? Or anyone played with any of these that I haven't seen before? So like Datastore. I only found that 2 days ago when I was researching my slides again. Nope. Okay. So what is a document store? It's usually considered to be a subclass of key value store because of the way the primary lookup system works. But most document databases have a secondary lookup system, so a query language or a MapReduce like CouchDB or different implementations of them. You can find some older CouchDB that have a plugin which allows you to just roll Lucene inside of its architecture, so you can have a Lucene search on top of that. We also then implemented that in Cloudant. But there are, different ways of doing it. So it's quite resilient to different kinds of queries and different kinds of lookups, different things you need to do to it. What would you use them for? These are operational databases. So they are the thing you would do your normal day-to-day work in. They store your users, your products, your individual records. And because they are NoSQL schemaless, you can just iterate and make the documents larger or smaller as necessary. You can have nested records within them to have a normalized-ish sort of system. But the documents themselves, and the metadata in there provides you with everything you need to do the querying. So the individual keys then become things you can look up on if you write the correct indexes on them. Most of these systems do follow the eventual consistency model. So Couchbase does, but because it does a lot of its work in memory, its eventual consistency is freaking tiny. Cloudant, because it writes to disk, slightly larger. CouchDB, same bag. Essentially anything that follows the DynamoDB sort of white paper approach to distributed systems has this eventual consistency model just because of the way it has to maintain step between all the machines. But this does mean you still have the flexibility of changing your schema as you would with any other schemaless system. Right, next up, column data stores. Who wants to take a shot at naming some of these? There aren't that many. Yes, that's my favorite at the moment, even though trying to implement something that forces gossip to behave is painful. If you let gossip just do its thing, it's amazing. But if anyone want to try and name any others? Okay. Well, there aren't that many this time. Cassandra, HBase, and Accumulo are the only ones I've really played with. Nobody will give me credit to play with Google Cloud's Big Table, so I haven't had a chance to play with that yet. Anyone here played with Big Table? Damn it, I really need to find a good reason to play with it. But these are, once again, used as operational data stores for a lot of things. It does internally actually hold things in a table-like structure. When you look at a table in Cassandra internally, it kind of looks like an Excel spreadsheet, where instead of having null values, the field just won't exist if you haven't posted it in, but it will still be stored roughly as a table, purely because that's how it builds its indexes. So it just goes, yeah, that's an index, it's an index, it's an index. Makes it quite fast to look up. It makes it quite useful, especially things like Cassandra, where it doesn't worry too much about the eventual consistency model, because for low-level merging of information, it has a vector timestamp which allows it to tell, well, this one's newer than that one, so that must be the same, and it will provide you with a winning revision that is a lot more accurate. They are kind of relational in that way, so you do look at one table, you do pull in and out of it. It's the reason why CQL works brilliantly, is because it gives you this flat SQL-like implementation on top of a relational-ish system. And the brilliant thing is, because of the fact you can just post and pull out, change the schema as you want, the table fields kind of just expand and contract with each row as necessary. That's how it kind of works internally for Cassandra. Can't remember how it works for HBase, but I can't imagine it being classified as a wide column and not following the same sort of model. So why would you use them? Once again, they're an operational store, kind of relational, and these things are massively distributed. They are designed for massive network failure. Who here has read the stuff about Chaos Monkey at Netflix? Everybody here should read the paper on Chaos Monkey at Netflix. One, it will make you hate what they do because they seem to do it all so much better than you. Let's just turn off an entire region to see what happens to our system. In production, I would spend a decade trying to convince my boss that we should try this, and it would still never work. And you know what? They do this on a regular basis. The Chaos Monkey system, I think it's Kong, the one that just knocks out regions, and Chaos Monkey, which knocks out individual machines. These things are designed to be resilient. Machines just dropping off the network, so it's redistributing information internally quite naturally. So if you want it, they're great. You can also use them for time series. There is actually a specific type of database for time series, which contains databases like Druid. But Cassandra, because of its whole vector timestamp stuff, does mean it does time series quite well because of the way it just keeps iterating on the timestamp, giving you an index on it. This is my favorite one at the moment, graph data stores. These things are insane. When you look at the architecture for them, you cry at the genius of these people and then worry about where they're going to go rampaging through next. Anyone want to try naming some? That's technically a multi-model, which is painful because everybody can say it, except it's a multi-model, so I've had to skip it off my slides. Any others? Neoforge, yeah, that's right. That's the most popular, the most well-known one. Technically not open source. OpenCipher isn't even open source because everybody on their commit board is from Neo4j. We'll make it open source and then control everything. Defeats the point, people. Right, so these ones, Neo4j, Giraffe, Titan. Titan's my favorite because we've been rolling that internally for a new product as part of a Tinkerpop stack. And it's insane because it then just goes layers deep. Also, TitanDB doesn't actually store any of its own information, just as an FYI. TitanDB is weird. It stores it in another type of database. Mostly BerkeleyDB, Cassandra, or HBase. You plug that underneath it, and that's where it stores your information. But it's still a graph database because it does everything in memory. It grabs it all from these reserved data sets, grabs it together, data munges it, and then spaffs it back out at you as a graph, which is great. So what are graph data stores? Simple. Who here remembers any of the graph theorem? Okay, I'll go through the basics of it. It's where you take distinct records, nodes, and the relationships between them, edges, are what are important. So you have individual people, so Dave, Derek, Fred, and the relationships between them of friends or family or spousal are the edges. So you can hop along from Dave, Derek, and Fred by going, Dave is a friend of Derek, who is the son of Fred. And these relationships provide you a very powerful means of categorizing and hopping around. And it's really, really quite powerful stuff because these are designed to run in the 1 million+ records all in memory so that it's just hopping around doing, yes, you can very easily cause cyclical path errors by just going around in the circle millions of times. But if you write your query well enough, you'll skip that if you put a loop counter on there and you'll just have this wonderful path set where you can get some really, really magical things. Oh, who here remembers 6 Degrees of Kevin Bacon? The connection between Kevin Bacon and anyone else in the movie industry, otherwise known as the Erdos number. Right. After this session, you should sit down, Google 6 Degrees of Kevin Bacon. You will A, laugh yourself senseless, and B, this whole hopping around between actor, film, actor, film, actor, film, ad infinitum will make sense. So why would you use a graph system? You can do pretty much the same thing in graph as you can in SQL, because in SQL and you can just think of a graph connection as a join. So 2 datasets join, dataset join. Difference is graphs are designed to do these joins at 1,000 levels deep, whereas if you tried doing that in an SQL service, I'm pretty sure you'd A, run out of memory for the temp tables, and B, it would be the ugliest query to debug ever. So you would never run this in SQL because you'd write lock, you'd run out of memory, well, sorry, read lock, run out of memory, and it just looks god awful and really painful to go through. So some of the best uses for this is social graphs, Erdos number, Kevin Bacon. Recommendation engines are traditionally a graph sort of solution. So being able to look through thousands of product purchases by people, matching them against different products and sort of smushing it together to give you a relevant list. These are really good. So this is finding patterns in data to give you a recommendation. There is then the anti-pattern, which I keep forgetting about, which is fraud detection, where you take all these millions of transactions, find what is considered to be the general same pattern, and then go, oh, there's a random payment from Saigon. That's probably not real. So you can find matches and things that do not match a given pattern inside of a graph system, which are really, really good. And as I said before, you can offload those massive memory-hungry queries onto a graph that you would normally run inside of an SQL service. So that was me talking quite fast for quite a long time. I'm really sorry. Thank you for the heckling. I appreciated it. Need more coffee. So, rejoice. It's almost over. I'm about 10 minutes early as well. Nuts. So, what we've learnt. NoSQL is a lie. Who would agree with me on this statement? Hands up or hands down? Hands down means you believe NoSQL is a generic term that covers all databases. Wow, you still believe that? Nobody believes me that NoSQL is a lie. Okay. So we now understand why NoSQL grew up. It grew up from the age of commodity hardware, increasing distributed systems, making them affordable, and having to maintain state across thousands of machines. We now know it's a bit of the right database for the right job. Postgres is not the answer to all things, neither is MongoDB. Neither is MySQL in some cases as well. You can just pick the right tool for the right job. You've got a graph problem, pick a graphs database. You've got simple lookups you need to do. Why would you bother throwing that in an SQL service and clogging it up? Throw it at Redis. Right tool for the right job. Some different uses for these different databases. Did the use cases I gave you make sense? Would you agree with them, roughly? Cool? So, yeah. Right tool for the right job. I still use PHP and I love this picture. Respect the double claw. So, right tool for the right job. Makes life so much easier if you're using the right thing to get the job done. As I said, if you want a quick lookup, use Redis. If you want to be doing a really complex query, use Graph or SQL. If you just want to have something small and portable which can be thrown into a mobile app, probably you want to go with CouchDB, Couchbase, something really lightweight. If you pick the wrong tool, chances are you've all been in the same spot where the tool just doesn't fit the job and you spend months and months going around in circles trying to make it fit. Who's been in that situation? Yeah, I'm pretty sure everybody who's a developer in this room should agree with me. They've spent weeks and months just going, this doesn't work like this. I should find a better tool, otherwise I'm wasting my time. I was expecting more nods, but okay, I'll take that. But if you do it right, it's a thumbs up. Things can go in the right direction. You can make things work the way you want them to work, and it's all good. So, I'm Mike Elsmore. Those are the details for my talk. If you want to take a photo of that so you can steal any of the URLs and names of things, I'd do so now. Right. I need more coffee. Right, there we go. Right. I need more coffee. Really need more coffee. But what are the questions? Oh, is that a question or stretching? Pardon? OLAP. Right. So can I compare NoSQL for OLAP? Well, NoSQL services can be OLTP or OLAP. Things like Tinkerpop, they actually can be both by having a batch processing backend to do OLAP queries, so kind of in the same way that Spark Submit works. But they can also be OLTP. So you can have in small clusters an ACID system. So a single node of CouchDB is ACID because what you're putting in is what you're getting out. It's when you start getting to larger machines, the moment you have to have that eventual consistency model for the AP machines, you just lose ACID. You just can't be OLTP at that point. But you can be OLAP because you can throw larger batch queries and just leave them to run process at the back end. As far as I know, the best ones for this are Titan, Accumulo, and Neo4j does have large batch processing. So they work in the same way as a traditional OLAP-based process. but most of them try and follow a more OLTP process, purely because they're all designed for Web 2.0 fast querying. Much of the quote marks for that one. Did that answer your question? No worries. Anything else? Come on, I'm not that scary.
Do you have an idea of the traction of NoSQL databases in terms of how much do they draw from the traditional SQL in terms of solutions for use cases that you presented here?
Yeah. Right. So, two most common databases on the planet, MySQL and Postgres. But when it comes to prototyping and smaller projects, if you check, if I think somebody did at libraries.io did a scan of projects on GitHub and compared them for what database drivers they were using. It's not so much, there is a growth, and there has been a growth for the last 6 years, 7 years, from moving from SQL to NoSQL for prototypes, small systems, just the web hackery and student sort of events, and also for things like mobile dev with the advancements in the fact that of mobile apps, but they still all need somewhere to store things. Things like CouchDB and Mongo, Couchbase, Cassandra have all become more prevalent because they're just faster at taking in large amounts of writes and just dumping them in. So the idea being, if you have a mobile app, or you don't need it to read that often because it's got a local copy, you just need to have a remote version of it to compare against everybody else. So it just needs to receive thousands of writes. An SQL service traditionally doesn't have that sort of massive write amount because of the fact that when you're running larger systems, you've got a master-slave set up, and there's one machine which is doing everything, and it bleeds out. But SQL is never going away. NoSQL is not a replacement. That's a complete fallacy. As I was saying before, it's the right tool for the right job. In a financial institute, you wouldn't roll Mongo for your bank data. That's a bad idea. You'd be having 3 different machines on the planet having $5,000 removed all at once. That's a bad thing for somebody who's got 20 bucks in the bank. So yeah, no, SQL and transactional systems are going to be around forever because they have their place. It's the same with NoSQL. There is a place for them, and they're not going away. The growth, I believe, on average is, last time we checked, something like 1.8% of projects on GitHub are including more NoSQL, in the broadest of terms, technologies inside of their systems for their repos. But how much that actually counts in the proprietary world, I have no idea. Not sure most of them are going to let me sniff around their code to do a check. Does that answer your question? Sort of. There is no answer because there's no way of knowing what every developer on the planet is building.
No, but the question is not so much from the perspective of the developer, but for example, you work for IBM.
Yes.
And IBM has a number of commercial databases.
Yes, we do.
Which are SQL databases.
Yes, we do.
And do they, for example, see or consider NoSQL as something to worry about in terms of competition?
Yes, they do, because we've been stealing their work for the last 2 years. However, just to point a fact on that, the transition within most businesses that do databases, it isn't from the fact that SQL is getting their work poached by NoSQL. It's by the fact that people are moving more and more onto SaaS products. So databases that can run as a SaaS system are poaching more. So a SaaS NoSQL service is more likely to poach an on-premise, run-it-yourself database. There's the difference. When IBM and the other large companies get their SQL services into the cloud in a way that developers can consume easily, then it'll start leveling out again. Is that a better answer? Sorry, my bad. Anything else? Because it's really quiet in here. And I'm really loud and need people to talk to. Wow. Oh, wait, there we go. One more in the corner.
Are there any tools like that integrate all the processes like SQL and NoSQL? Like customers focus or interest to have tools
I have been spying on specific projects which are linking systems together. For example, I've been looking at a project recently which connects Cassandra to Redshift, which is essentially a Kafka-based sync tool for passing the information through based on the Cassandra Deltas feed. So there are tools. They're all homegrown, baked on by somebody who's building it for their need. As far as I know, none of the Apache projects are running tooling for migration between the systems themselves, but there are plenty of people building tools around that for it, especially when it comes to moving between data warehousing and BI systems and their operational stores. So a lot of BI and data warehouses are still very much SQL-based because that's what you want to do, those kind of deep, strange queries to find out random information, which you can't do in an NoSQL service. So there are definitely systems which are piping from operational NoSQL services into SQL systems. However, there are very few systems doing it the inverse because it's just so hard to write MapReduce queries on top of SQL easily that actually work everywhere. That's very much down to the developer of the individual system they're building, unfortunately. Does that actually answer your question? Yeah. Sweet. Can I get coffee now?
Thank you very much, Mike.